Hello, this is Dr. Johnson Steigelman doing yet another test of this. It looks like I have to wait a little bit for the stream to go live. So I'm just going to test this out. This is a lesson on the simple pendulum. During a normal lesson, I would talk about what we're going to learn in the lesson, kind of go through these objectives, and then I would actually go into the talk. Okay, so this is the free body diagram for a pendulum. You can see you've got the length, you've got the angle. The angle is measured from the center out, so there's theta is equal to 0. And you're going to take a look at the information for the free body diagram. You've got Fg, you've got the force of tension, and it's easiest in this case, like most cases, to break this into components that are in the direction of motion and parallel to the tension. Okay, it turns out that this angle theta and this angle theta up here are equal to each other. You can do a little bit of geometry to show that, and once you have that angle, you realize that because it's not moving, the string isn't changing size, the tension and this component are equal to each other. That component is Fg cosine theta. The other component is Fg sine theta. Notice because of where this angle is, the opposite side is down here, which is the same length as this guy up there. Okay, now we're going to apply the small angle approximation to this, which we often do. And the small angle approximation is the sine of theta is equal to theta minus theta cubed over 3 factorial plus theta to the 5th over 5 factorial minus theta to the 7th over 7 factorial. And this would continue on using the odd numbers. Now, pi radians is 180 degrees or 3.4159 radians. We're going to look at small angles less than 20 degrees usually. And if I do that conversion, 20 degrees is about 3.49 radians. And if I take the sine of that, notice that 3.49 radians, take the sine, is equal to 0.342 with no units, of course, because the sine function gives you something that is unitless. Okay, so the small angle approximation, notice that this isn't quite equal to each other, but in most cases, if you get less than 20, this gets better and better, that the sine of theta is approximately equal to the tangent of the theta, which is approximately equal to the angle itself, as long as you keep it in radians. So by all means, 20 degrees, if I pop that in here and took the sine, it would be the same number, but 20 is nowhere equal to this. So you do have to be in radians. Okay, I'm going to stop the stream here and see how it went.